So guys, the expectations here is that you check your answers. So you can see you got your answers A through I, and then if you are having any trouble with any of those answers, you're going to listen to this recording for number 7, and then if you don't have any questions, you can start working on your homework 2. But then as soon as I switch to problem 8, you guys need to tune back in, check your answers to number 8, and so on through those 4 problems. So looking at number 7, hopefully you'll recognize this. That looks similar to one of our example problems yesterday, that when the current leaves and it travels down this pathway, because there's only one pathway that is in a series circuit, and then at this point the current has a choice to take this pathway or it's going to take this other pathway. So even though it looks a little bit different than other problems, that's where it turns into a parallel circuit. And then at this point, it becomes a series circuit again back into the battery. So to find the total resistance, you're going to have to find the equivalent resistance of the 10 and the 15 ohm path first. Right, so 1 over your RP, right, is 1 over the blue path, 10, 1 over the purple path, 15. Remember that that total is equal to 1 over the total resistance of the parallel path. So make sure you, once you add that, you take the inverse of it, and that gets you 6 ohms. Now, once you know that that purple and blue act as a 6 ohm resistor, that 6 ohm equivalent resistance would be in series with this 6 ohm resistor, and therefore you can just add the two together to get the total resistance of 12 ohms. So moving on to part B, if you want the current that comes out of the battery, of course current is using Ohm's law, the voltage of the battery divided by the resistance of the battery. So the battery is 36. We just figured out in part A that the total resistance is 12. So we know now that 3 amps comes out of the battery, and everywhere where there's a red line, because that's in series with the battery, there's 3 amps. So moving on to part C, what is the current through the 15 ohm resistor? So I think the easiest way to look at that is take the total current that comes out of the battery, right, our 3 amps from part B. And because we're looking for the current down this pathway, you're going to take the resistance of the other parallel path, so the 10, and divide it by the total resistance of both pathways, so your 25. So that's where the 10 and the 25 come from for that problem. So that gives us, right, the 10/25ths, right, or what would that be, 2/5 of the 3 amps goes down that pathway, which comes out to be the 1.2 amps. Now the current that goes through the 10 ohm resistor, or our blue parallel pathway, well, the total down the purple and blue pathway has to be 3. So if 1.2 amps goes down the purple pathway or through that 15 ohm resistor, then 3 minus 1.2 is going to go down your blue pathway. So moving on to part E, right, the power of the battery. I think with power of the battery, the easiest thing is to do is the current coming out of the battery times the voltage of the battery. Let's see if I can find that answer somewhere in there. There we go. So the current coming out of the battery is your answer to part B, 3 amps. The voltage of the battery, of course, is listed as 36. So that 108 watts is how much power is delivered to the circuit from the battery. Part F, we want the current through the 6 ohm resistor. Well, you can see here that this 6 ohm resistor is part of that pathway that is in series with our battery, which means all of the current that comes out of the battery has to go through that 6 ohm resistor. Therefore, the current that goes through there is the same as the battery, so it's 3. There's no work needed to find that answer. Part G, the voltage of the 10 ohm resistor. Now remember, parallel paths have the same voltage drop. So whatever voltage is lost down the 10 ohm or the blue path side is going to be equal to what's lost down the 15 ohm side. So if you find one, you already know the other. So looking at that, right, you can use Ohm's law where V equals I, the current, down the R. So down the pathway, right, we want to know the current down the 10 ohm side, or the voltage that's lost down the 10 ohm side. So we want the current that goes down this pathway, which we've figured out to be 1.8 amps, right? So that's our 1.8. We know that the resistance down that pathway, of course, is our 10 ohms. So our I times our R gets us the voltage drop of 18 volts. So moving on, like I said, the voltage drop down the one pathway is equal to the other. So you immediately know that the voltage drop down the purple pathway or through that 15 ohm resistor is going to be equal to that 18. And for the last part of number 7, the voltage drop of the 6 ohm, well, you could do that a couple different ways. If you know that you have to have a total loss of voltage of 36 and 18 volts gets lost down the parallel path, you could do 36 minus 18, or you can calculate it out using Ohm's law. 3 amps goes through that 6 ohm resistor, right? It has a resistance of 6, so it is I times R, and that gives you your total voltage drop down that or through that 6 ohm resistor. So moving on to number 8, I'll let you check your answers for a second. In this circuit, right, we have current that is going to come out of our battery, and it's going to travel through this 13 ohm resistor, and there are no options. It has to go through the 13 ohm resistor. At that point, that's where we get the break, right? At point E, you can decide to take this pathway to B, or you can go to D, around to C, and to B. So the blue and the purple are parallel pathways. Now at point B, the current that went down our EB pathway and the current that went down the EDCB, or the purple pathway, those come back together, and now all of the current has to go through our resistor and back to the battery. So again, everything in red is in series with the battery, so whatever current comes out of the battery goes through those two resistors, and then the current that goes down the 7 ohm and the 9 ohm part, those two are going to equal that total resistance. So the first thing you got to do is find the total resistance, and you have to take our blue pathway, right, and our purple pathway and figure out the equivalent resistance of that pathway, which means, oops, that's the wrong one. Uh-oh, can't go backwards. Anyways, where is it? There it is. So down the parallel pathway, right, you have 1 over 7 plus 1 over 9. Make sure once you add that, you take the inverse of it, and that gets you 3.94. Right, now remember, that's within 0.1 of a whole number, so I'm going to end up eventually rounding that to the whole number. So this, again, this 3.94, right, I'm rounding to 4 essentially when I'm making the answer. Now that I know that this 7 ohm and 9 ohm parallel path act as a 4 ohm resistor, right, that simplifies my circuit to where now I have, right, you have your circuit, you have your 13 ohm, you now have your 4 ohm, Sorry, I'm doing this with a mouse, not with an actual pen. Then you have your 3 ohm resistor, and so your circuit should now be a simple series circuit with your 13, right? Your combination here of 4 and then this 3 ohms. So that's why I'm adding these three together. The equivalent parallel path of 4, the 13 on the bottom between F and E, and the 3 between A and B are all in series. So adding those together, you get your total resistance for the circuit. Let's see here. So moving on to part B, the current from the battery, of course, that's going to always be the same. Once you find this equivalent resistance for part A, or the total resistance, you're simply going to do the voltage of the battery divided by the total resistance. So 800 divided by 20. So for part C, the current that goes through the 7 ohm resistor, right, our blue path in here, because that is part of the parallel path, it's going to be less than the 40 amps, right? But we know the current that goes down the blue path and the purple path, they have to add up to 40 amps. Well, there's a couple different ways that you could find it. And I've discussed those ways a couple times. So in this case, I'm going to show you something a little different than what we did in number 7. So you can take the equivalent resistance of the pathway, right? Up here, we said that the equivalent resistance of our parallel path is essentially 4, and that's what this number is. And if this whole pathway, right, if this equivalent or parallel pathways acted as a single resistor, all the current that comes out of the battery would go through that equivalent resistance of 4. So voltage is I, 40 amps, times the resistance or equivalent resistance of the parallel path. So 40 times 4 is 160 volts. So you know that you lose 160 volts down the blue pathway and also down the purple pathway, because parallel circuits are always the same. Now, once you know that voltage drop, now you can use your Ohm's law equation again, right? I equals V over R. Down, again, we're on part C. So down the 7 ohm side, you lose 160 volts, right? You lose your 160 volts, and then it's divided by the resistance down that pathway. So from A to B, there is a total resistance of 7, and that gives you the 22.5 amps. So 22.5 amps goes down the blue path, which of course means that 40 minus 22.5 goes down the 9 ohm, or down that purple pathway. So that work there is showing you the other method of finding the current, right? You're going to take the total current out of the battery, 40 amps. You're going to, right, again, if we want the current down this purple pathway in here, you're going to take the resistance of the other pathway and you're going to divide it by the resistance of the 7 and the 9 together, right? So 9 plus 7 is 16. That's where this 16 comes from. So 40 times 7 divided by 16 gives you the current down the 9 ohm pathway. So there again is an example of how to do the two different methods. Oops, I don't want to get rid of all those. Too late. That is the two different ways of figuring out the current down parallel pathways. So moving on to part E, right, we want the voltage drop from B to E. So from B to E, well, we've already kind of figured that out. Up here, it's 160 volts. But now that you know the current that travels from B to E, right, down this pathway, you can take, right, if voltage is I times R, you can take the current that goes down that pathway, which we figured out in, where was it? Part C, right, 22.5 amps. and you're going to multiply that by the resistance down that pathway, which is 7 amps. So 22.5 times 7 is going to give you the current down that pathway. Wait, what did I just... That should say, this here should say volts right here. Sorry about that. Units are volts. Okay, moving on to F. For part F, it wants you the voltage drop from C to D. Well, this parallel pathway has to be the same as the voltage drop from B to E, so it's going to be the same answer, right? Which you can see here, right? Is they're both 157.5. Which really, I believe it's supposed to be 160, but because we rounded this back here, it kind of went off a little bit. I got the wrong units again, right? These are volts. This is volts. So there we go. Moving on to G, what is the current through the 3 ohm resistor? Well, this 3 ohm resistor is in series with the battery, so there's no math needed. It's the exact same current that comes out of the battery. Part H, what's the current that goes through the 13 ohm resistor? Same deal. This is in series with the battery. There's only one pathway here, so all 40 amps goes through that 13 ohm resistor, or goes from F to E. Which brings us to the last one, letter I, the voltage through the 13 ohm resistor. Well, voltage equals I times R. So what's the current that goes through the 13 ohm resistor? We've just figured out it's 40. And what's the resistance? Well, it's 13, right? So 40 amps goes through the resistance of 13 to give you your voltage drop from F to E, which would be 520 volts. So moving on to number 9, let you check out the answers there for a second. Hopefully it's getting a little bit easier to identify these series and parallel paths. So current's going to come out, it has to travel through the 20 ohm resistor, so that is in series with the battery. Again, at point A, you can get to point C this way, or you can get to point C by going through B and around. So everything in the blue path is parallel to everything in the purple path. It comes back together at point C and goes back to the battery, which means the 8 and the 20 ohm resistor are in series with the battery, and the 3 and the 6 ohm resistors are parallel paths to each other. They're not parallel paths to the 8 and the 20, just to each other, the 3 and the 6. So again, starting out with simplifying that 3 and 6 ohm parallel path, right? 1 over 3 plus 1 over 6 is going to be 3 over 6. Take the inverse, right, or 6 over 3, right, which gives you 2 ohms. So this parallel path right here can be simplified down into a 2 ohm resistor, essentially, right, where you're going to have your battery, you have your 20, this is simplified into the 2, you have that 8 ohm resistor, and it comes back around, right? You've got your, it's hard to draw with a mouse, you've got your 8 ohms, your 20 ohms, and the equivalent to the parallel path, the 2 ohms. So looking at that picture, right, the 20, the 2, and the 8 are in series together, so you would add those 3 together to get the total resistance of your circuit, which is our 30 ohms. Moving on to part B, Current through the battery, well, that's the same, right? We've done that, seems like a million times now. So the voltage of the battery, 1,200 divided by the total resistance of the circuit, 30, gives us the current that comes out of the battery. Part C, let's see if I can get rid of some of this stuff. Right, part C wants us to know the current that goes through the 3 ohm resistor. Well, sorry, just hiding a yawn in there. So the current that goes through that 3 ohm resistor, there's a couple different ways, right? There's always 2 different ways that we figured that out. I'm going to show you what I think is the easier or shorter way. So 40 amps goes from A to C, right? Either down the blue or the purple path. So that's why I got the 40, right? It's the current that comes out of the battery. And because we want the current from A to C, you are going to take the resistance of the other pathway, right? So from A to B to C, that pathway has a total resistance of 6. And then the 2 pathways together, right, have a total resistance of 9. So you've got your 6/9. So 6/9 or 2/3 of the 40 amps goes down that blue pathway and through the 3 ohm resistor. So the work for, that's definitely not the right answer. The work is right, the answer's wrong. I didn't fix that. So the work for part D here, right, the current down path BC, it's really down path ABC, right? Everywhere in that purple pathway is the same current. You can do 40 minus 26.67, right? Because the total down these 2 pathways has to equal 40. Or you can do, or you can do the work that's here, right? 40. I want the current down this pathway BC, so I'm going to use the resistance down the other pathway, which is where the 3 comes from, right, over again the resistance of both, which is the 9. So 40 times 1/3 is not 26.67. It is 13.33. So this, again, hard to write with a mouse. 13.33 amps goes down that pathway. Part E, what is the voltage drop from A to B? Well, that's easy. If you're focused on A to B, there's no resistance. So if there's no resistance, there's no loss of voltage, therefore it's 0. Moving on to F, the voltage through the loss through the 20 ohm resistor. This is in series with the battery, so all 40 amps goes through that 20 ohm resistor because it's in series with the battery. So voltage is I times R, so it's 40 times the 20, giving you that voltage drop of 800. For part G, you need to figure out the current, right, that goes from D to E. So from D to E, well, that is in series with the battery, so there's no calculations needed. All the current that comes out of the battery has to go down that pathway, which means, what did I just do? I don't know what I just did. This, I have no idea what this is. This is what happens when you do work really quickly because you know you're going to be absent the next day. Right? There's no work there. It's 40 amps. Sorry about that. Now I've shown you part H. The power through the battery, of course, that's I times V. The current that comes out of the battery is 4. The voltage of the battery is 1,200, giving you the power that the battery supplies to the circuit. So part I is asking, of that 48,000 watts, how much power does the 6 ohm resistor, how much power does this 6 ohm resistor use as the current's traveling through there? So in that case, I like to use I squared R. So the current that goes down this whole purple pathway, we've already figured out to be this current, right? 13.33 amps. So that's gonna be my I squared, 13.33 squared. And then of course we want the resistance of just the 6 ohm resistor, so the R is 6. Right, so 13.33 squared times 6 gives us the power that is used by that 6 ohm resistor, or dissipated by that 6 ohm resistor. Give you a second to look at those answers. So number 10 is a little bit more complicated, not too bad, but a little bit. Again, current comes out of our battery, right? It is going to travel through our 7 ohm resistor. All of it has to go through the 7 ohms. So it is in series with the battery. At that point, at point B, you have a fork in the road. You can travel down this blue pathway, and if you do, you're going to go through the 3 and the 2 together, which means the 3 ohms and the 2 ohms, right? These are in series together, because if you go through one, you have to go through the other. Now, they're not in series with the 20 or the 7 or the 4, 3, and 1. They're just in series with each other. If you go down the other pathway, right, if you start going this way, you have to go through the 4, you have to go through the 3, and you have to go through the 1. So that means that the 4, the 3, and the 1 ohm, those are in series together. So because these are in series together, right, you're going to add those together. So 4 plus 3 plus 1, right, gives you 8. So the purple pathway acts like an 8 ohm resistor. The blue pathway, well, right, the 3 and the 2 are together, so that acts as a 5 ohm resistor. And so we have a parallel pathway of a 5 ohm resistor and a parallel pathway with an 8 ohm resistor. So to do that work, see if I can find it in here, click on the right thing, right? The 1 over 5 is the blue parallel path. The 1 over 8, right, is our 4, 3, 1, or our purple path. So 1 plus 5 plus 1 over 8, take the inverse after you add those together, and it comes out to be within 0.1 of 3, so round it to 3. So now I know the blue and the purple together act as a 3 ohm resistor. So now, again, right, you have your 7 ohms, your equivalent resistance of the parallel path, which is 3 ohms, the 20 ohm light bulb, and so you have your 7, your 20, and the equivalent resistance of the parallel path of 3. And so those are all in series now together, so you can simply add those together and get the total resistance of your circuit, which is your 30 ohms. Part B, always the second part, right? Total voltage of the battery divided by the total resistance of your circuit, which you found in part A. Part C, the current through the 7 ohm resistor. Well, this is in series with the battery, so no math needed. If 40 amps comes out of the battery, right, all 40 amps have to go through that 7 ohm resistor. And by the way, once you get to point A, right, the current will go through here, which means the 20 ohm resistor is also in series with the battery. So what in part D, what's the current through that 20 ohm resistor? Well, it's all 40. Part E, what is the current through the 4 ohm resistor? Now it's just asking what is the current through that resistor. Well, you can see it's part of that purple path. So if you can figure out the current that goes down that purple path or that parallel pathway, that is going to be the current that goes through not only that 4 ohm resistor, but the 3 ohm resistor and the 1 ohm resistor. All three of those resistors will have the same current, just like over here the 7 and the 20, because they're in series together, they have the same current. So to find the current that goes through this 4 ohm resistor, I'm going to find out the current that goes through that whole purple pathway. Right, so the total current coming out of the battery is 40. If I want the purple pathway, then I'm going to use the total resistance down the other pathway. That's my 5. Right, then I'm going to add all of these together and put that on the bottom of the fraction, which is my 13. Right, so 5 over 13, or 5/13 of the 40 amps, goes down the down the purple pathway. Well, at that point, if 40 amps comes out of the battery, right, then the blue and purple have to equal 40. So if 15.4 go down the purple, then 40 minus 15.4 goes down the blue. Right? Or you can do the work for that where, let's see, where does it ask for that? Part G? I don't know where part G is. There it is. Right? So you could do 40 minus 15.4, or you can do, oh man, I really did this too fast. Right? Or you can do that same fraction deal, right? So down the blue pathway, you would take the resistance of the purple pathway, so your 4, 3, and 1 add up to 8, right, over that total of 13 again. So 40 times 8 divided by 13 is not 15.4, it is 24.6, right, which was right here. So sorry to go back to part F, right? It's asking what is the current through the 1 ohm resistor. Well, this 1 ohm resistor is parallel to, or is in series with the 4 and the 3. So whatever current goes down that purple pathway goes through the 4, the 3, and the 1. So the current through that 4, 3, and 1 ohm resistor is 15.4 amps. Okay, part H. Getting close to the end here. Part H, the power through the 7 ohm resistor. I squared R is the easiest way to go. So because the 7 ohm resistor is in series with the battery, all 40 amps goes through that resistor. So we're going to do 40 squared times, right, we only want to know the 7 ohms, so 40 squared times 7. For part I, the power of the battery, I always think it's easier for the battery to do I times V. So, right, the I that comes out of the battery is 40. The V of the battery is 1,200. So 40 times 1,200. Part J, the voltage drop across the 20 ohm resistor, right? So if voltage drop is I times R, the current that goes through that 20 ohm resistor, we said, is 40 amps. And the resistance, of course, is 20. So 40 times 20 gets you the voltage that's lost there with that light bulb. Part K, the voltage drop of the 2 ohm resistor. Right, so we want to know, we don't want to know the voltage drop down the whole blue path. We want to know just how much is lost on that 2 ohm resistor. Well, if you voltage drop is I times R, right? Well, we've figured out that 24.6 amps goes down that blue pathway. So that's going to be our I. And our R, of course, we want to know the voltage drop only with that 2 ohm resistor, so our resistance is 2. So 49.2 volts is lost just right here, right? If you did the 24.6 amps times the 3 ohms, that would give you the voltage drop there. If you did 24.6 amps times 5 ohms, that would give you the voltage drop total down the blue pathway. Moving on to L, what's the voltage drop of the 3 ohm? So like I said, I did this one. I know it doesn't really specify, but down this pathway, 24.6 amps goes down that pathway. Even though it says the current of 24.6 is the 2 ohm, because that 2 ohm and that 3 ohm are in series together, that means that the same current goes through both. So 24.6 amps goes through the 3 ohm resistor. So again, voltage is the current times the resistance, or I times R. Which finally brings us to our last one, right? Part M, the voltage drop from A to B. Well, we've just figured out that the voltage drop of the 2 ohm is 49.2. And we figured out the voltage drop of the 3 ohm is 73.8. So you can add those two together and get the voltage drop, right? Or you can do that same idea of 24.6 amps goes through both of these. They're in series, so you add them together. So 24.6 times 5. So I know that was fast. Hopefully it was able to answer your questions and help you out. So you are going to work on homework 2. It's going to be due tomorrow. Make sure you're doing it on a separate sheet of paper following that same format, right? Part 1A or 1A, skip a line, then 1B, and then 1B, skip a line, 1C. Folding your paper hot dog style again, if that's working, if you write small enough for that to work. And otherwise, make sure you do those problems. And I believe I assigned 1 through 6. So I have 1 through 6 done by tomorrow, and we'll see you then.